all joining with us today to our very first Georgia Precision Poultry Farming Conference. You know, the term precision poultry farming and precision agriculture is a relatively new term. In actuality, for us within poultry sciences, we've been applying different technologies now for different decades. And I think this is a recoin of some of this focus. But some of the technologies and integration of those technologies are very new for our poultry sector. And that's some of what we need to unpack today. So what I thought I'd first do is frame the conversation for today, just by, myself kind of thinking through what is precision agriculture. So I went to one of those first resources we all think of for definitions, Wikipedia. So looking at how precision agriculture is defined by Wikipedia, they define it as a farming management concept based on observations, measurements, and responding to inter and intra-field variability in crops. Fairly short-sighted. Us in the livestock sector don't get included, at least within Wikipedia. The goal of that precision agriculture is really to define a decision support system for whole farm management with the goal of optimizing returns on inputs while preserving resources. Okay, so let's think about that a little bit further. If we Google another term and come up with precision livestock farming, a probably more exacting term, and one of those terms that was coined largely from efforts in the European research community. And really, it's the use of advanced technologies to optimize the contribution of each animal, providing continuous automated real-time animal monitoring to improve production, reproduction, health, and in particular welfare. And I point this out a little bit because a lot of the research base to which this has garnered attention is largely coming from the academic community, and therefore, in part, that base of what needs to be brought through from a public perspective. But I still think this definition is somewhat limiting because if we unpack a little bit of that, what we term advanced technology in its application, there are a whole host of segments across the poultry sector where advanced technologies could be utilized to garner some additional contributions to efficiencies across that production stream. So if we think of agriculture in general, and this is from a few years ago now, 5 years ago, looking at how digitally advanced different sectors are, agriculture tends to fall at the very bottom of that list of digitization. Right, and that's digitization across asset utilization, usage, and as an example in daily business practices or daily operations, or utilization by the labor force, again, falling fairly low. However, if we think about the food production sector and everything involved within the food production sector, we're poised very well for what we would call application of advanced technologies. And so if we look at this graph here, let me pull up a laser pointer. You see that we, within the food production sector, have a very data-driven mindset, and we relish and have access to a whole host of data. That poises us very well. So that's just one, and I'd say that's more in the food service arena. However, if we look at transportation and warehousing, very IT intense. If we look at other production sectors within, which I would call agriculture, is poised very well for utilization and intensification of IT-driven applications. So we're poised very well, but falling further behind on lists versus other particular segments of society. So if we take a look back to that Wikipedia definition for precision livestock farming, and unpacking a little bit of that advanced technologies. Really, I think that definition is fairly narrowly defined, and as we unpack those terms within the poultry segment, there's other applications and a great host of applications to which those advanced technologies could benefit our poultry sector. Those could include the feed milling, formulation world, transportation logistics. Certainly, we see more advent within the processing sector to utilize and each cut and maximize yield. We see it coming into the food safety realm, but we also see need and want and desire from our commercial customers as well as that end customer for transparency and traceback issues through where advanced technologies could gain a foothold. So with that in mind, that I wanted to poise today's conversation into the utilization of precision technologies into poultry farming. So if you think of individual words, individual words as it comes to advanced technologies, there's several things that at least came to my mind. On the positive side, we think of them being predictive. We see advances in robotics and automation. We see those tools allowing us to make better decisions based on data. We see better documentation of processes that we are going through for verification with that end customer in mind, partly leading to more transparency. We see utilization of more sensors, providing them more data. And we see integration across our production systems to a level we have not seen before. So those are all the positive attributes. Part of what I think we want to unpack today is a little bit of how we could better position the poultry sector to begin to be able to adopt some of these additional technologies. And that isn't without some of its struggles. So we want to unpack some of those things that are stymieing some of the application. Just some thoughts initially on where those are, and we have some speakers today talking about this particularly. Data quality, reliability of data. Who owns the data that are coming across these systems, especially in our contract live production realms? If we're looking to workforces, we need to make sure that they are indeed data literate, which is not always the case. And as we produce different sensors, we ultimately are concerned in placing them in fairly harsh environments. So the longevity of those sensors, and especially if we're wanting then to create an integrated system, we are very concerned about our rural connectivity issues that we see and deployment and receiving data from those particular sensors remotely. So I wanted to have a little bit of that conversation to essentially poise the rest of today's conversation. So I give Lee Long a lot of credit for putting together this effort. I always present this particular slide when I'm talking about our faculty, because really we generated this slide really to help guide us as a guiding star towards the 5 different emphasis areas within the department that we're focused on. Those 5 being food safety and processing, production and management systems, bird physiology, metabolism, and omics, bird health and well-being, and last but certainly not least is our poultry scientists, our future generation of leaders going into the poultry sector. So as it comes applicable to today's conversation on application of precision poultry tools, Lee Long certainly is getting into that area as he builds his programmatic efforts on extension and research. We've been fortunate as well amongst our faculty to add another faculty with us at the beginning of the year. Our upper administration at the university went through cluster hires 2 years ago as well as currently. with an emphasis area in precision ag. So we were one of the early benefactors to receiving a precision poultry position with that interface of how we assess and can automate some of the well-being attributes and utilize different means to assess animal well-being. So Prafula Ragmi joined us at the beginning of January. So I'm looking forward to what he will bring to some of that conversation within the department. Of course, we're not alone in Georgia. And I could say that's one of the fun things, at least in going through this conversation, is because we have a wealth of collaborators, not only on the private side, with not only the poultry integrators, but also the supply chain of those technologies. And we're seeing that supply chain grow. And part of today's conversation is to bring a recognition to Georgia for what it has to entail. And hopefully some of those that are building some of those technology and looking for those applications would think of Georgia as a home. On the public side, beyond ourselves in the Department of Poultry Science, we're located within the College of Agricultural and Environmental Sciences. We have a counterpart, what I call a sister department in the College of Veterinary Medicine, the Poultry Diagnostic and Research Center. Also within Athens, we're home to USDA's Ag Research Service, National Poultry Research Center, and our other collaborators in Atlanta at Georgia Tech through the Agricultural Technology Research Program, and we'll hear from a couple of their folks later on today. So it's really this network across these different entities that really brings Georgia to a very unique place, and we often refer to it as the epicenter for poultry sciences in the world. The other fun thing for me, at least as we try and position and grow into application and utilization of different technologies, one of the biggest things that we've been involved with in the department is a campaign for a new building. Our 1958 facility that we're currently in is not best poised for us to develop some of those technologies and develop new students as they're going into the poultry segment. The good thing is that we have received 2 infusions of funding from our state legislature, one last year for architectural funding. We're really knee-deep at the moment in the design phase for that new building. And the Georgia legislature did budget and approve that budget this spring for an additional infusion. We're waiting the governor's signature soon, hopefully, for half of the public funding for this, half the funding coming from the public for this new building. The other half is from private partnerships that we're working with very actively. Our potential move-in date for this new facility would be then the fall of 2023. So it's going to be happening very soon, and we're very excited for the opportunities for what it could bring us. For those of you that don't know us as well, we are one of 6 remaining poultry science departments. We are home to roughly 600 students, both at the undergraduate and graduate levels. Just to give you an idea for our graduating class, both fall and spring, those entering into the poultry segment directly are at about 28 students, which is a little bit up for us in terms of graduates, but certainly a far cry for what the poultry sector is needing for future poultry leaders. Our graduate student numbers are growing, and I think we're predicting a class of in the fall of roughly 60 to 65 graduate students coming into the department. And really that gives me a lot of excitement and encouragement because they are really the drivers for a lot of our research endeavors. One last note, if you're new to the department or have known us for some time, I'd say one way to really connect is through following us on social media. Either through Facebook, LinkedIn, or Instagram. There you'll find everything from updates on research that our faculty are doing to tidbits on getting to know some of our students, what they're up to, as well as some historical flashbacks. And I included one here in the middle because it is apropos to today's conversation, because it is one of those advanced technologies that we were looking at back in 1968, which was really that mainframe computer at a commercial entity in Atlanta to do real-time least cost formulation on diets. So a little bit of historical flashback, but if you haven't connected with us in the past, please do so through those different venues. So I welcome you on behalf of the department and the University of Georgia to our very first Georgia Precision Poultry Farming Conference. Leilong, I'll turn it back to you.
Thank you very much, Dr. Applegate, for the introduction. Any questions for Dr. Applegate? Yeah, we have a lot of students today. If you future have any question about a poultry science department and about our research, feel free to reach us. Okay. Our next speaker is Dr. Cassie Reed. Dr. Reed is a professor and the extension program coordinator in the Department of Poultry Science at UGA. Dr. Reed has been an extension faculty for over 28 years, working with poultry producers on litter management, environmental and waste management issues, and agricultural zoning regulations. Welcome, Dr. Reed.
Thank you, Leland, and I appreciate the opportunity. All I would really want to do today is just welcome you to this new program and to extend our appreciation for your support of our extension programs. For those of you who are not used to or understand the concept of extension, really it's at a research land-grant university system, it's a three-pronged effort from the university: a research, teaching, and an extension, or what we often call public service or public outreach. And that really is what our goal and our mission is to help to disseminate agricultural technologies and information that assists our agricultural communities and industries. And really, with the efforts that we put forth in our extension programming, we're thankful for our sponsors and for the support that we have of our not only our local industry, but also worldwide, of those who are looking for information and new technologies. COVID-19 has taught us a couple things. Yes, it's been it's been a pretty rough year, 14 months for us all. But what it has taught us, I think, is that our programs are really needed, and that we've also found, I think, a new voice through online technology that we really weren't exploring as much, I think, from our extension programming standpoint. And I think what we have learned is that we really can reach to many people throughout the world with these online formats. And so going forward, I'm sure we're going to continue to have some kind of a hybrid program where we not only have face-to-face training opportunities, but also some of our online programs that certainly can reach more people, and particularly areas of the world that can't readily travel to the United States for some of the programs that we have. So really, I just want to, again, thank you for being a part of our program today, this new program. I thank Leilong, Dr. Chai, for putting in the effort with this new programming effort of his. I remember, I think my first program years ago now, I think I had like 15 people. my first program. Of course, it was a face-to-face activity, but I really applaud him for the effort that he has made, and for you all for participating today. So again, thank you for being with us today, and looking forward to having a great meeting. Li-Long, back to you.
Thank you, Dr. Reed. If you future you have any extension questions, please feel free to reach Dr. Reed. Our next speaker is Dr. David Wicker. Dr. Wicker is the Vice President of Livestock Operation at the Fielddale Farms Corporation. Dr. Wicker is a native of South Carolina who grew up on a family poultry farm. He received the BS degree in poultry science and a doctorate in nutrition and biochemistry from Clemson University. He joined the Fielddale Farms as the Director of Nutrition and Technical Services in the Live Production Division in 1995 and was promoted to Director of Live Operation in 2007 and then named Vice President of Live Production in 2010. He has over 40 years experience in poultry industry. Welcome, Dr. Wicker.
Thank you, Dr. Chai. If we can go to the slides. Yes, we're getting the slides up. I'm assuming that you can see the slides.
Not yet.
What about now?
Good, very good.
Good. You can go to full screen. Very good. It's my pleasure to be with you this morning and discuss some of our activities in commercial broiler production. Let's go back one. With you this morning. Some of these activities we've been doing for 20 or 30 years. Others have been as recently as this past year and the year before. So it gives you an idea of what we're doing. And this one.
No, just move it.
Let me see if I can get the slides. There we go. And I have 4 primary areas I'd like to go over with you this morning and spend most of the time on the first 3 because artificial intelligence analysis of input data is still in very beginning form. And these areas are, as Dr. Applegate had pointed out in his presentation, precise use of nutrients to meet the broiler's requirements. And I'm glad that he put in welfare because I put in and society's needs requirements. And just to give you a little bit of this, of course, use of ingredients to color the skin of the chicken has been used for 30 years. However, more recently, we're concerned with paw quality, leg quality, and that does change our requirements for certain nutrients. And society's needs will be more recognized and nutrient requirements changed as more information is developed. All right, second area. We can make the best feed, manufacture the feed, which is the first area. And then we're going to go to the production house. And again, as Dr. Applegate pointed out, we need increased and more precise monitoring of the housing inputs. We made a big change 10 or 15 years ago with going to controllers, and we need another big change in the next coming few years. It will increase our efficiency more so than the change from mechanical devices to electronic controllers and then going to computers and computer analysis of this data, which is the third item. You can collect thousands of input data points. And can you monitor all of them? Can you interpret all of them? And then, most importantly, take action. We need a computer monitoring of this data and reporting of this data. And then the last one, which we'll do very little, is AI, artificial intelligence, has shown potential in other areas. In our area is mainly still data collection and then trying to measure something. So let's go to the first one. And what we do is precise measurement of nutrients, ingredients, etc. And we require them on a daily basis for nutrient analysis. And we use near infrared and have been doing that for in excess of 25 years. And when I say daily, we will receive a train of corn analysis and new trading rules and transportation rules. We have 24 hours to unload 90 rail cars, a little bit over 10, 11,000 bushels in less than 24 hours. So we have storage for up to 3 weeks of corn. That is the good news. The 2 weeks of that storage is in one huge silo. So I have about a week to 8 days of corn storage that I can receive corn, put it in there, and get an analysis the next day prior to using it and reformulate our diets with it. And of course, what we're doing is near infrared to get your approximate analysis, moisture, protein, fat, etc. And then we're using equations developed by the various companies, amino acids, Evonik, Adiseo, Energy with Trowel, the Dutch researchers. We're actually studying some of the French work with net energy assays, but have not switched from our traditional assays yet in the equations that are developed. Again, we get the samples, come in, and they're analyzed that day and the next morning. And when that train load of corn, and we don't use it all at one time, so we may be using 20 cars and put them in silos, I get all these values back and I know which silo these are in. And to just go over this data a bit, what you're looking at, this is 103 corn, or general corn. It's in feed mill 2, as you can see there. We have a lab ID number, a sample date, and you can see all of these are from 410, early in the month of April. We have the supplier. And then I have, in this case, the rail car number. From this, I can tell you which 4 elevators in Indiana that this corn came from. For example, we get a good bit of corn from the Tifton elevator in Tifton, Indiana. And what the primary breeders of corn have told me is most of that corn will come within 75 miles of that elevator. And of these elevators, I have about a 25-year history. So I'm just looking at how much they're varying. So coming over here, we've got protein, fat, moisture, and these are all by NIR. And then I also take a subset of samples for minerals, but they're by inductively coupled plasma. And it takes at least 3 days, 4 days, but fortunately minerals do not change a lot. And coming down through here, I usually just scan these, and you've got one large value here, and most will not change very much. And in our data analysis, we would probably just ignore this one and leave it in. If we found one that was greatly varying, we'd throw it out and redo the analysis. Let me go to the next slide, and you'll see the summary. Still have a few samples here, but here's what I'm interested in. I like to see at least 20 samples. And the standard deviation on this one is very good. I like to see, as a general example, 0.34. Now, fat varies very low. And of course, moisture has varied in here. And I like to look at the min and max. And again, looking at the individual values, how they change. This particular set of corn samples is a little bit high because looking at this several times each week, I know that the average corn moisture is about 14.4%, not 14.85. So we would take this and these corn silos, take our equations and readjust for moisture content, and protein content appears to be about the same, so we would not readjust. And how often do we reformulate? Anytime that we see a significant change in an ingredient that would affect the nutrient intake for the broiler. Going to the next slide, we do the same thing for soybean meal. You can see the same type of data, lab ID, sample date, and these were on April the 6th. Supplier was Cargill, except for one from Bunge. And this is a key point. Over the years, because freight cost of transporting ingredients, I know that 95% of my corn is going to come from area in Indiana, with just a little bit over in Iowa, and occasionally going up into Minnesota. So I know the elevators I'm going to pull corn from. Very similar with soybean meal. I have a Cargill crush plant 30 miles away. 80 to 90% of my soybean meal is going to come from that crush plant. Cargill has another one in North Carolina, occasionally pull from, and also Alabama. ADM and Bunge also have a few, so we will pull from ADM and Bunge. But you can see here, this is a very consistent number of, and the other one, which I didn't mention with corn, all these ticket numbers portray to either a truckload or a rail car of corn. So I can trace that back to the area it was grown. And in the case of identity preserved corn, I can actually trace it to a farm. I cannot do this with soybean meal. I can trace it back to a crush plant. And then Cargill may have received the beans from Georgia, Mississippi, or in most cases from the Midwest because of freight rates. So bean source does make a difference. And we, when we see a major change in these, we'll ask the crush plant, have they changed bean sources? And here you can see one outlier, and they occasionally have these. The average was 46.94, and this one was significantly different. And you ask why? They added in a lot more fat. Fat averages about 1.7 to 1.8%, and this one is definitely an outlier. It's not moisture, but it is fiber. And this is an official sample continuously collected. Now, we look at these, one for protein, because that's where we're developing all of our amino acid values we're putting in. Look for fat, because of the energy content that may change, and moisture. And these are official samples, so they'll tend to be a little bit less moisture than the actual samples. We'll actually take samples from the rail cars themselves, composite them to 5 rail cars on a composited sample, and trace the moisture. Moisture on soybean meal actually runs about 12, 12.2, 12.4%. So just to give you. And fiber will change with, get my pointer back here. Fiber is 3.5, which is not bad, but you can see there's quite a bit of variation from all the way from the 4%, a lot in 3.7, and that varies a lot. So we're looking at it again, moisture and fiber, mainly as diluent of nutrients going into the birds. So these are what we're looking at. We're looking at these on a daily basis. So we're looking at this supplier for a location that we can trace. And our goal, of course, is to develop precise nutrient values for each ingredient and adjust them as needed. Very similar to corn, I have about a 7 to 8 day supply of soybean meal in the feed mills themselves, and then we're storing on rail cars out on the yards about another 2 or 3 days of supply. So I'm going to have about 2 weeks of ingredients most of the time, because here recently transportation is an issue with not only truckers, but also with train crews. So we're very cognizant of trying to keep an adequate inventory in case of storms, weather, or something happening. And this time period gives us enough time to do NIR and get precise nutrient values. Anytime these change to a large degree, then we are reformulating. And that can be as much as about every 3 days. So we're doing it 2 to 3 times a week. And at times when they're very stable, we might not change formulas for a week to 10 days. You can see here the samples, and what I like to see on these is a standard deviation. And this is only 16 samples. I'd like to see about 20 samples again. Slightly lower in this, instead of 0.41, I'd like to see about 0.34, maybe 40 on the max side. Standard deviation here for fat, 0.23 is very good. Moisture, and in this case, fiber is pretty good as well, and not a huge variation. The other one, we try and work with suppliers. If we can pick up when suppliers have mechanical issues, as in a soybean crush plant, and our goal is for the supplier to call us and let us know that we may see a significant change in the nutrient profile. So if they don't call us, then we will detect that change, and then we will send an email to them. So we've detected a major change. What is happening? Will you improve in 2 days, which is typical for a mechanical issue, or are you inspecting lower quality for a week? And that allows us to anticipate what's coming in and make adjustments to what the formula will be. And again, this is why we have all of this history, and we will share it with our suppliers. We'll share both the good and the bad with them, and we're expecting feedback that if they have a problem, to call us. Very similar on the corn, which I did not bring up. All corn samples take an official sample. We got the national grain standards for test weight, moisture, broken kernels, fine material. We receive that information the day the grain is loaded on the rail cars in the Midwest. So we'll have about 7 to 8 days before that grain arrives on site. We also have them assay for mycotoxins. And then we know that in not this year's grain crop, but the grain crop in 2020 had significant mycotoxins where we were pulling from. And we were able to have those mycotoxin assays and know that 5 cars of corn in this train of 90 to 100 cars needed to be isolated. And we would isolate it and use it at very low levels with a mycotoxin inhibitor. So just some of the things that are very more precise. A partnership arrangement with your suppliers is very good. And in addition, we use it. We encourage a lot of local production of corn, milo, winter peas, etc., from the farmers around our area. And so we can also analyze local ingredients as they come in and assign them to a bin. So it has helped us tremendously to get accurate nutrient values for formulation and meeting the bird's requirement. If I go to the next slide, there we go. All right, you can formulate the best feed out to 4 decimal places. The next question is, how well can you make that feed? Because you might formulate the 4 decimal places and you can only mix feed to 1 decimal place. And feed manufacturing is extremely important part of precision nutrition of animals. And I'm just going to give you 3 because this is an entire day-long presentation in itself. So I'm just going to give you 3 of the things I like to look at. One is ISO 9001 certification, and the actual certification is ISO 9001.2015. And why is this important? It's the basic idea of ISO. All of us will make mistakes. All of us will make them every week. So ISO says we make a mistake, we determine the root cause, and then we come up with a solution that it will not happen again. So your constant improvement. You should not make the same mistakes over and over and over again. And that's a bit of a simplification, because sometimes you'll have a steam problem with the boiler and it may take you 3 months to get it corrected. However, you know what the problem is, the mistake, you know what the solution is, and you're working toward a solution and constant improvement. So that gets you toward excellent feed manufacturing. Now, one you can do and check, and we do mixer profiles. We do them at least once a quarter, and we do finished feed assays, and we look with our veterinary people and our role of supervisors in the field. If we see a problem we think is related to feed, we may do more frequent mixer profiles. And the current industry standard is a coefficient of variation on a particular added ingredient of about 10%. And there's a lot of discussion, it should be more accurate, and I agree. What I have found over the years is a good mixer should mix with a coefficient of variation about 2 to 2.5% above the assay variation of the ingredient being measured. For example, we use added dry D-L-methionine. If you go out and analyze 25 or 30 samples of added methionine in the feed, that assay variation alone is somewhere in the 2 to 3% range. And then if you add 2 to 2.5% upon that, you get that your mixer should have a CV for added methionine about 5 or 6%. Now, that is for added methionine. If you were to do minerals and calciums, that is a different number. So be aware of measuring one like methionine that has the same bulk density of most of your feed ingredients, and then measure one that has a different bulk density, such as a mineral. And then you know that you're mixing the feed correctly. The other one you need to do on this is you need to do finished feed assays. Go to the next slide. And here we have the same type format. Get my pointer here again. Here we go. Same type. We have a lab ID number, a date, and this was, we actually do some non-GMO feed. So this is a broiler finisher feed. We have a feed ticket number, and that's very critical. It has the type of feed on it, which is this data, which truck it was loaded on, the tare weight, the gross weight, the time it was loaded, the farm it was going to, and all the appropriate FDA data on that. That allows us to trace that feed to a farm, or if we have a problem on the farm, trace that feed back to the feed mill, trace it back to the ingredients that were being used in these lots of feed. So we have complete traceability on that. And so these are the ticket numbers. This one came out of feed mill 1. We have 2. And again, we're looking at the same thing. I'm looking for how protein varies in this one. And of course, how fat varies. Again, we're doing this by NIR plus moisture, but minerals we're doing by inductively coupled plasma, and we do less. We don't see a need for all of them. Going to the next slide, which is a summary. Very similar to what we saw earlier on the ingredient side. Again, I like to have at least 20 samples. We had 19, so it's fairly good. We have a protein here, value of 18.6, and a standard deviation of 0.57, which is a little bit higher than what I'd like to see. I'd like to stay under 5%. And I'm going to point out one more thing. These are not my nutrient minimums. The actual nutrient protein it runs on here and I keep one just for observation, is a little bit above 17%. This particular formula is running 18 because of ingredient variation, and then the amino acid minimums are driving this protein up, not a protein minimum. So don't interpret any of these values as a nutrient minimum. They just happen to be what we're running. Fat is accurate here because it is by our nutrient assays. These are not accurate because we're using phytase, and then you had to add the phytase back on the calcium, phosphorus, and sodium to get actual values that are delivered to the bird. What I'm looking for here is the variation, and these are all very good. We also follow potassium because we're using primarily corn and soy diets with no meat products. So our potassium tends to run high. And starter diets, it'll run up about 0.9%. And I'm interested in that from a society standpoint and also an economic standpoint of pulp quality, because higher potassium will cause increased water excretion and then pulp problems if your ventilation in the chicken house is not accurate. Moisture, this is a little bit high, and we use this plus inventories in the feed mill of ingredients, daily inventories of what should be used and what is actually used. The feed mill is actually gaining about 0.4% moisture on me. This formula should run about 13.4 according to calculations. And this tells me that we need to go back and look at our coolers and throughputs to get the moisture back down to the level of the ingredients that are coming in the mill. And that's important because if you get too much moisture in your final feed, you're diluting the nutrient package that you're giving to the animal. So these NIR and precision analysis, and I say precision, some people question the accuracy of NIR. We've been doing it for 20 years. I have a wet chemistry laboratory that I periodically run samples both for NIR and in wet chemistry. And they agree closely. Now, it's all in one lab, all in very good conditions. The laboratory scores and ring tests with American Association of Feed Control Officials or American Organization of Official Analytical Chemists, ring test, round robin test, where you have unknowns, scores in the high 97, 98 percentile. So we know our values are accurate. We routinely check them against wet chemistry. Next slide. All right, we can formulate a great feed. We can manufacture a great feed. And this will lead into my other one, because getting that feed to the correct farm, the correct house on the farm, the correct feed bin on the farm has been difficult, and I'll give you some over time. 10 years ago, I had two farms. One was Gary Wiley Farm and one was the Sharper Wiley Farm, located across from each other on a highway. Even though that feed ticket that I spoke to you earlier about had the correct location, the correct directions, it said go down 365 and turn right for the Gary Wiley Farm. Undoubtedly, a truck driver would be easy eating lunch or thinking about something else. You'd go down 365 and turn left and go to the Sharper Wiley Farm. What we ended up doing was making sure that those farms sold in the same week. So if they put the feed on the wrong farm, it was still the correct nutrient profile. We had other problems with growers naming farm oak, twin oaks, triple oaks, Oak Grove, Oak Manor. And we finally made a rule you cannot name another farm oak in any kind of way. More recent one, we've had a tremendous influx of Asian growers. And a lot of them have the last name of Wynn. So we've tried to correct it with farm name. Each farm has a unique number that identifies it. And we try for unique names on a farm sign that's at the entrance. But for whatever reason, we will occasionally see a load of feed delivered to the wrong place. Now, the more precise, and then once you get on the correct farm, you got to have the correct house on the farm, because our houses, you can back a feed truck up between two houses and have access to 4 bins. So we like to have the correct feed bin loaded with the correct feed. And how we've solved some of these. All trucks are now equipped with GPS, global positioning systems. We know from the feed ticket that the truck was empty, the tare weight. When we loaded it at the feed mill, we know exactly which feed it was loaded with. We know the time that it was weighed and the time it left the feed mill. We have the exact miles that it's going to the farm. So we know that when leaving the feed mill, it should be a particular farm 30 minutes later. We can check it with GPS. So I now will know that it went to the correct farm and generally the correct house. What we've done in the last 2 years is put feed bin load cells on the bins. So now I can actually tell you it went to the correct farm, the correct house, and we have a possibility of 2 feed bins for each house. When the truck stops, there's actually a possibility of 4 feed bins, but I can tell you that feed went into the correct bin on the farm. And this is a critical. Our feed systems, a number of them, 2 feed bins or 3 feed bins will feed with 1 auger system and deliver the feed to the house. We have 2 feed bins per house, and each has a separate feed delivery system. That way I know that when the start of feed is delivered, it should be consumed on day 15, very early on 16, and that this bin should be empty. That's critical for several things. I want to know when that nutrient package that we precisely formulated, precisely manufactured, and delivered to the correct bin was consumed by the animal. So this is the type of data that we're collecting. And feed bin scales do this. Looking at the next slide, and this slide is distorted because I wanted to get the actual picture of the load cells, and this is a retrofit. This farm did not originally have load cells, and you can easily retrofit these to the feed bins. And it gives you a very accurate number of the feed. The next slide will give you the readout itself. And this one is shown within the sanitation room. Gives you the amount of feed that's left into that bin. And that is very critical later on when we're collecting data, because I would like to know the amount of feed consumed by that house within 30-minute or even 10-minute increments. And this is the only way I know that you can get that kind of precise data. Now, this scale also brings out a problem I'm going to discuss later. We have these also on the outside of the feed bin, and that's great because feed truck drivers will come up and for whatever reason, you would think they could know what an empty bin sounds like by tapping on the side, but they still make mistakes and put the feed in the A bin when it should have been in the feed B bin. When that happens, we go back out and pick up the feed, and if it's something or mistake that we can rectify and use the feed, we do. If not, then we dispose of the feed in a landfill. So you catch a lot of mistakes with these feed bin scales. The other one, we had one of the people we're working with, and it was a good idea, did away with the digital readout and just made a transmitting unit, and then made an application for your phone so that you pull this data up and look at the inventory in that bin from anywhere you were at, up at your residence or out somewhere in the community, and you could look at it at any time. And this is a case I wanted to bring up on analysis of data. Most young people carry a phone with them, and young folks are 45 and under. and they have access to this. Most of my older growers, and my average age of growers is 60 years old. That phone resides in the pickup truck of the John Deere Gator. They do not carry it on their person, so they do not use apps. And in a number of farms, we had to go back and reinstall these digital readouts. And I bring up this interesting aside is you have to take into account the owner of the farm and how they use current technology and future technology and adapt it to the owner of the farm. And it'll become more critical with things other than just feed bins. So this is a tremendous one we have there. Going to the next one, and I want to go to the away from feed production to precision broiler production and measuring within the house. Controllers have done a fantastic job of measuring many inputs. Dr. Mike Zarek and Dr. Brian Fairchild at the University of Georgia done a lot of excellent research on measuring these. And we can measure temperature, ammonia within the last few years, humidity, feed consumption we've talked about, CO2 and oxygen are big ones that are being proposed to be measured in Europe. But according to our own data and Dr. Zarek's data and Dr. Fairchild's data, CO2 and oxygen are not a problem in our housing systems when we are ventilating for humidity. And the reason I'm using humidity is we use ammonia control agents. And sometimes we are ventilating for ammonia, but most of the time we're ventilating for humidity and later in the year with temperature. So CO2 and oxygen are not as big a factor as what we see. Water consumption. We've had water meters in the houses for many, many years, but the grower had to go in, read the meter reading every day, write it down and calculate how much water was consumed. And what we found with more precise water consumption, where we put this either into a controller that you can look at more discrete intervals, or better yet to a computer program where you can measure it in 10-minute increments, you get a lot of differences in water consumption. Our newer houses, we're doing the brood end versus the other end of the house. And to give you just some of the things that you can determine. If you turn out the chicks from the brood end and they're going to the other end of the house, if water consumption is equal on both ends of the house, you have a good distribution of chicks. And that is very important this time of year coming up, that when we will do tunnel ventilation shortly. So if you can get a good distribution of chicks, water consumption on either end of the house will tell you this, and put in your migration barriers, and you're good to go. If you do not get an even distribution of chicks, then you have to go and do some factors, get more even distribution of chicks, and you can tell it by water consumption. We are doing a research house. We're modifying some commercial houses. And in that one, I would like to put, it'll be 4 water lines, 2 on either end of the house, dividing the house in the middle. And I want to see water consumption by quarter of the house, because we have some limited input already that that will enable us to get more precise data on what that bird is consuming, both feed-wise and water-wise. Energy consumption, we're not measuring other than just basic gross ones, but this is one as more and more a society is interested in sustainability will be important. So it is down the road. And then I threw in the last one here, broiler activity, again, coming to Dr. Applegate, and we're looking at welfare and society's needs. They want to see the birds' activity, and we're working with some of the universities on cameras and looking at activity, and it also is an indication of how well that bird is doing. So just some more data that we're looking at. So these are precision data collection. And to give you some of this, we say precision data collection, and we found that even 1 degree at certain times in temperature will make a difference in grower performance. This is a house where we are collecting data. Not quite all of what you see there, but temperature, humidity, water consumption, feed consumption, etc. Off of bin scales, off of other sensors, and so forth. And what you're looking here, this is 8-house farm. I've just taken 2 houses, and I'll show you the 8-house data in a minute. And here what you're looking at is 2 houses. House 1 is the green line. House.
Both of them are house 1.
Oh, both of them. Yeah. Excuse me. Casey's correcting me. He is actually doing this work. Both of these are house 1 with the green line is feed and the blue line is water. And you can see this is 13, 14, 15. These are day. So you're increasing the feed consumption, lights go out, and then you start over again the next day. So you got daily. And here you have gallons consumed and pounds of feed in these houses. Now, what's interesting is this is the type of, even this should be more even, very small variation in feed and water consumption. There on 14th of August, we noticed a deviation, which you can see here in quite a bend. We first thought it could have been running out of feed, that the grower for some reason let them run out of feed, and you expect water consumption to drop. We also thought it could have been a vaccination crew had disrupted it. So I said, okay, didn't get too excited on this one. And then we come to the next day and it happens again. And then we come to the next day and it happens again. And then it happens again. And of course, we put the time in here. It's about somewhere between 10 and 11 or 12 o'clock every morning. Something is happening to this house. And what we found was that was the time, and because you can see here it is in August, that the cool cell was coming on. And then further looking at it, and I should, can you go back one? Looking at the temperatures and looking at the birds, going back to the house, we noticed that when this occurred somewhere around 10, 11:30 in the morning, all the birds sat down and stopped eating because the cool cell system came on too aggressively. The wind speed, combination of wind speed and lower temperature caused the birds to sit on the litter and stop eating for a while. And very simple correction. We raised the temperature where it came up 1 degree. 1 degree Fahrenheit solved this problem. So a grower would not detect this problem unless he spent a lot of time in his house. And most of our modern growers got 4 to 8 houses, and you just add up 30 minutes in a house 2 to 3 times a day, and he has a full-time job. He can't sit there and watch the birds unless he's very animal production oriented and walks in and says the birds aren't eating. Some of them can see that occurrence. Other people can't. They just see a bunch of chickens in the house. And it's a case of can't see the trees for the forest. But a computer program can bring it out, and you can pick it up relatively easy and correct the problem. Now, what did this mean for the grower? This grower was slightly above average, so he was not a poor grower. He was competing against the other 4 houses, which happened to be his sister-in-law, and she beat him every flock. And when he corrected this problem, he was able to settle number 1 in his settlement group. And his sister-in-law, which is still a very good grower, settled out number 4. All right. How much money did it need to him? This is about $1,000 per house. So do these programs pay? Yes. And this is one example, 1 degree Fahrenheit, very precise broiler production in a house. And we cannot measure this in most of our houses yet today. Next one. All right. This is all 8 houses, I believe,
Yes.
for water and feed consumption. So you can see in the house 2 water is something's wrong with the meter, so that's not correct. So just look at the majority of the graphs and curves. So if you're looking at this, you can see some things where we've made 12 p.m., 4 p.m. looking at variations, but you can't pick out the individual houses. And the problem with computer programmers is they're accustomed to dropping out of this screen, backing up 4 or 5 screens to a major menu item, coming over to individual houses, and dropping down 2 or 3 screens to go to that individual house data. That is a fine scenario if you have people accustomed to moving around screens on an iPad or a phone, because most of these guys are not at their house on the computer. They could be at night, but they're looking at this and trying to say, I've got a problem in the house. What is it? It's very difficult for them to move around. So current programs, we need to move from all houses to 1 house. I need to look at it in the 1 hour period between 9 and 10 o'clock. And I don't want to go through 10 screens to get there. I want to get there easy. And those programs aren't there yet. This is a difference between young computer programmers and particularly my growers who have an average age of 60. So we have to change our computer programs to make it more easily used by a age group that is more challenged with moving around data. The other problem with data is this farm is 8 houses. If you take a broiler supervisor, he has 20 to 30 farms and maybe 80 houses. He needs a program that he can look at all of them and look for abnormalities. He can't sit there or 2 mornings and look at it real quick. So, oh, that's my time period. And I'll go a little faster. So we need better computer programs to interpret this data. Whether you are a broiler production manager, a broiler field supervisor, or any of the others, it's a huge problem because a broiler complex production manager actually in charge of the houses may have 1,500 houses that he has to have a staff look at. Broiler weight scales. I'll go through these real quick, and this is not it is a picture of my chickens, but I stretch this side to side. Chickens do not look that long to give you a clear view of a scale in a house. And what we found, and the numbers other people have found, they're accurate to about 3 weeks when the birds hop on and off. If you're doing a small bird program, which we are not, but they can be accurate to about 1/10 of a pound. We have found that if we have accurate water consumption and this bird scale data, we can use a computer program to predict weights at tray pack weights, which is 6 to 7 pounds. And we can come within 1/10 of a pound, and some of them we miss about 2/10 of a pound average weight per house. So predicting bird weights for our uniformity of birds, for the average weight of the birds, because we're pulling them to meet a customer requirement for a specific size of meat. And that is a huge payback. Still needs work, but is showing a lot of promise. Next slide. The last one I want to talk about is artificial intelligence, and this won't take long. One, we thought about sufficient data. We took old data or existing settlement data for a year and put it in. And that wasn't enough because we measured traditional things, not all the items that I was showing you for temperature, moisture, humidity, feed consumption, water consumption, etc. So we're going back and trying to put in more data and hopefully the right data and quality data that we know that the data is correct. And then we were asking questions, is this a poor farm? What happens at day of age? How much weight we get? How much feed do we have consumed? And we didn't have enough precise data. So now we're going back and putting in what we have learned from some of these computer programs, for the example I gave you, and trying to ask correct questions. And we don't know the right questions yet. So this is going to take a lot of work yet, but it is being done, and very, very interesting. Next slide. Want to conclude, try to discuss 4 areas of precision broiler production with you. Precise nutrient analysis to meet the broiler's requirement, also society's needs and requirements, making that feed, delivering that feed, because if the broiler is not eating a precise feed, you can do the best formulation in the world. You got to get it into the bird, and he's got to use it. Again, a major one we're doing is precision broiler house monitoring. And I think we have a correct number of inputs. We may have to have more temperature sensors, more humidity sensors, but we are collecting that data. A major problem is getting that data from the farm, as Dr. Applegate pointed out, with transfer to a central location. And then we come to another one. We need better computer programs and monitoring to bring out these very small differences so we can take action on them. If we don't take action, we haven't done anything. And of course, we covered artificial intelligence just a little bit. So thank you for your time. And I have Mr. Casey Middlebrooks, who has actually been in the houses here and monitors all of these data senses. And Mr. Ken Martin, who is the production manager with 1,500 houses that he has to follow every day. So, thank you.
Thank you, Dr. Wicker. We got some questions. The first question is, microtoxin test is carried or not at the lab on daily basis? If yes, how often we need to do it?
We do not do it at the lab because we found that our problem is corn. So we identified which ingredient is the problem. In our case, it was corn. And at the grain elevator, as they're loading the rail car, they take a continuous sample. And that sample is analyzed for a number of things. We found out that our problem was DON and fumonisin. So we actually paid for the grain elevator to have these samples run as the rail cars were loaded. And therefore, it takes about 10 days for the rail car to go from Indiana to Georgia. And then I could identify which cars were a problem and isolate them when they got here. I have looked at soybean meal, and with our suppliers, it is not a problem. So we look at each ingredient, identify which one is a problem, and then we assay it. We also have the capability of assaying within our lab, and this is the way we determine which ingredient is the problem, and when we take what action we take.
Are there any known field test kits for microtoxin testing in feed?
I didn't understand.
Are there any known field test kits for microtoxins testing in the field?
Yes, and there are a number of new ones being developed. And our goal is to, one, detect it before the ingredient becomes in our feed mill. And if we get it in our feed mill, to isolate it and then use it at levels that are below research determined levels that would harm the bird and or put in a mycotoxin inhibitor. And that's been very successful. We had one of our worst years for mycotoxins in 2020, and I had said some of the best performance we've ever had as a company. So it can be done. But there are field tests, and I would recommend them. In our case, I've got a central lab. All of our farms are within 50 miles of the central lab. I collect the sample and just bring it back in the central lab where the assays are more accurate.
Okay. Thank you very much, Dr. Wicker, once again.
Thank you. Our
next speaker is Dr. Darren Kutcher. Dr. Kutcher is an associate professor and the extension poultry specialist in the Department of Animal Sciences at the Purdue University, Indiana. Dr. Kutcher's research projects are focused on addressing industry concerns in meat birds and laying hens. His program's focus is poultry well-being coupled with food safety and quality as impacted by management practices, physiology, and nutrition. Welcome, Dr. Kutcher.
Thank you, Dr. Shai, and welcome from Iowa. I'm currently at an egg processing plant, and I've been assured that we should have a stable signal, so we shall see. Can everybody see the PowerPoint okay?
Yes.
Thank you. So today I've been asked to visit a little bit with you about alternative egg production systems and some management considerations and things to think about. So I thought we'll give you kind of an outline of where we're headed. I want to first give you some historical perspective to really kind of ground us in where we've been and where we're foreseeably headed, what some of those challenges and opportunities are as we move forward, and then a short summary. So I think it really has to start off by having this conversation about perspective, right? So if you're the guy on the left side who's been stranded for years on this little desert island, you are really excited about the fact that this boat is coming. From the other perspective, though, if you're the gentleman who's been lost at sea forever, you're really excited by the fact that you finally get to see this land. And so when we start looking at hen housing systems and looking at where we are headed with table egg production, it's important to understand where we have come from, and that perhaps it is time for some changes to occur. And also understand from the other side that while we may be making changes, we can inadvertently cause other problems that we aren't anticipating. And so our perspectives are really going to matter as we look forward. So if we go back and, we dig up some historical pictures, this would have been common in the 1920s to have a small farm flock that you would go out and collect your eggs from on a daily basis. And if you had a surly rooster, then he may become your chicken dinner on Sunday evening. And so this is what everybody started with. This is kind of where we think about if we start talking about table egg production. We have a lot of people, consumers, that are still envisioning this type of a scenario. In the 1950s, though, it became obvious as we were concluding the world wars that we could start to increase our protein production to help feed our growing populations. And so the conventional cage became the first staple of a new type of production system in which we could actually produce our eggs. And there were some great benefits to moving our birds off of the ground at that point in time and into conventional cages to produce our eggs. In about 2000s, though, we started to see a dichotomy in consumers. And the reason this sticks in my brain is around 2000 is when I read an article that was in like Better Homes and Garden or something like that. And they were talking about this chicken coop here on the left that some people in Hollywood were now building these elaborate, $10,000, $15,000 chicken coops for their 6 chickens to have eggs in their backyard. And so we started to see this shift from the way that we were producing our eggs on the right in the conventional cage and starting to see more and more people that wanted to actually produce their own eggs and maybe have 6 to 10 birds themselves. In 2017, though, if we start to look, this is when we're really starting to see our cage-free production come online around the US. And we're seeing all of these various sorts of iterations. And so we are moving towards something new. And the question becomes, what is it going to look like? How are we going to deal with it? And what are the challenges that are associated with it? So if we take a moment and we think about our conventional cage, we know a lot. We have been working within the constraint of a conventional cage for 60 plus years. We've really honed in the nutritional aspects of what those birds need. We've learned how to effectively vaccinate them, how to really manage them. We figured out that if we can do smaller group sizes, we have a little more control over negative behaviors that we don't want to see. And so we've really focused in the past 60 years at refining this management system and being able to really effectively utilize this to produce our eggs. Now, as we start to move forward, though, the question is how much of this becomes translatable? So in the past 10 years, we've really seen this increase in alternative housing. And we have lots of factors that are causing this. We have some coming from animal rights groups, and that may be driven through legislative actions. It could also be that we're hearing that market demand is changing and that consumers are wanting more of these cage-free eggs. That's still out there to be seen. But regardless of these changes, we know that there will be an increase in cost. And so this is where the real test comes for consumers, is the understanding that while we may be wanting these new types of housing systems, and we're going to be pushing us this way as we produce our table eggs, at the same time, there will be associated costs. So we're going to have to expect to see this translation into the marketplace where we're going to have to pay more for the type of eggs that we may desire. So if we go back and we look at our stats, roughly 72% of our current flock would have to be cage-free by 2025. We know the reality is that we're not going to be able to meet that. Part of it is we can't build cage-free housing systems fast enough. If we went out and took a litmus test today of the inputs for feed costs right now, where the egg market is, I'm not sure anybody would be wanting to try to push bringing on more cage-free eggs at the moment. The other thing is we're in this conundrum because the industry is being told you need to move this way, but their customers are unwilling to step up and start purchasing those cage-free eggs because they want to wait until 2025 because of that known cost increase. And so it really is creating this perfect storm where it's unclear where we will be from the percentage of our flock that will be cage-free by 2025, but we will have a large or a fairly sizable portion of our laying hens housed in cage-free housing. So what are going to play into these trends? Well, we've already talked about those costs, the consumer sentiments, our egg price versus that consumer sentiment, and then what sort of state and national law changes. The one thing to keep in mind is that while we may have a state, and we'll use Indiana as an example, while we may not have a legislative mandate that states we need to be producing cage-free eggs, any of those producers wishing to sell eggs into any other state around them that has a mandate will automatically have to move to a cage-free housing system in order to meet those other state mandates. And so we're going to start to see that this is going to be a gentle push of the entire industry forward into the cage-free one way or the other. So I thought I would briefly touch on the different housing systems in case you're not familiar with the different types of housing systems for laying hens out there. And we're going to explore them from intensive to extensive systems. And what I mean by that is intensive, we can have a fairly small footprint, a lot of animal numbers, and minimal humans that are needed to help care for and interact with those birds, versus extensive, where we're going to start to give them more freedoms, more space, more area to do things. It also means we're going to have more labor in order to care for those birds in those systems. So if we look at our conventional cages, these are fairly typical pictures that we might see where we would have the stack belt system. And so in between each tier of those cages, we will have the manure belt to remove that manure. We may also have high-rise houses or A-frames where we can see that those cages appear to have an A shape, and below in the basement then is where the manure and excreta will be stored for a period of time before it is removed. Now, what are some of our advantages to those conventional cages? We know that we have cleaner eggs coming out because those eggs are able to move and roll away from those birds. We have smaller bird populations, and so we're going to limit those social interactions and give them a small defined flock size. We have an ease of management because we know that we can care for more birds because of the automated feed, automated water, and so we have a lower production cost. And for our workers, it tends to be a better working condition. Now, some of our disadvantages, though, is the birds lack that physical and psychological space, and we're not giving them the ability to exercise, really dust bathe, and express other natural behaviors. So while the conventional cages have some pros, they also have some disadvantages. But as we go here, you will see every housing system that we talk about will have some disadvantages. So the enriched colony cage, something we thought may start to take hold here in the US. And these are just some pictures of them installed. They're going to be similar to a stacked deck system like the conventional cage, where we have a cage and we have a manure belt underneath to remove the excreta. But within that cage, then, we're going to provide birds with a nesting area, which you can see in the upper left picture. And then we're also going to provide them perch space in the bottom right. So if we look at these advantages, they're very similar to the conventional cage. We're going to have those clean eggs. We have this ease of management. We also know that we're having a better working environment for our labor. And the other benefit we get by moving to the enriched colony cage is we can allow for more of that natural movement of those hens, and they can express some more of those behaviors. The downside, though, is that we may find that we have higher incidences of cracked eggs, and that's because we're giving them a defined nesting area. And so if you've got a size of 60 birds in that cage, and they're all trying to lay their eggs in this smaller defined area within a short period of time, we're really going to have to think about our egg belt management in order to reduce that incidence of cracked eggs. We may have more dirty eggs as a result of the bigger cage sizes and the ability to interact with those eggs. Additionally, that nesting area will have some sort of an astroturf pad, and so we have the potential then to amass excreta in that area. And this will translate into bacterial contamination on that eggshell. And so we're going to introduce inadvertently more bacteria or potential contamination of those eggshells with the bacteria from those nesting pads. Now, if we move to cage-free systems, it would be amazing if I could just say, here's one example of what a cage-free system looks like. But if we go back and we look in 2017, the United Egg Producers passed a cage-free definition. And quickly, what it means is we want to give those birds the ability to have that vertical access, that horizontal access, and we want to make sure that they have ability to scratch areas, perches, nests, other enrichments, and they have a litter area on the floor or some litter area that they can scratch from. And so if we use this broad definition, now we can start to see various iterations of cage-free come across. And so I'll quickly just touch on some larger categories. The thing to understand is that we can take any one of these categories, we could go out into industry and we can probably find 100 iterations within this one category of cage-free, because every producer is going to tweak it just a little bit to meet with their own preferences for what they would like to have in a cage-free system. So this is very similar to a high-rise slat house, where you can see we have the birds on an upper tier and they have the ability to come underneath, but you can walk underneath the production environment. This would be a multi-tier system. And so in this scenario, we can have it where the scratch area, again, is underneath or on the bottom of the floor. They have the ability to get up here to the feed and water, and then they have nesting areas in the center. And to show you some iteration, in this scenario here in the bottom right, they restrict birds' access underneath the system, but they give them exterior access to a scratch area. Here are some pictures to give you some ideas. So in the left picture, This would be a cage-free aviary with no restrictions. And you can see that they have some ramps here to help those birds navigate from the floor to the upper tier. And you will also see those birds would go jumping from this side to this side as well. In the bottom picture here, we can see that we have the housing system on the right side of the picture, and then we have a large open expanse for them to perform their scratching behaviors and other behaviors in the very center of the picture or on the left side. And this one actually has open access to windows and some other things to provide natural light. And then in the top one here is an aviary system, but they have pop holes because this was an organic facility to not only have the internal movement, but to also give those birds the ability to go outside and explore their environment, meeting the organic requirements. I'm assuming this video is playing, but trying to give you some perspective of what that cage-free environment may look like. In this house, there are 80,000 browns, and they have full access to the house. And so they have the ability to go from the very bottom to the very top with no constraints to navigate wherever they desire to go. Now, this is a different type of aviary system, and you can see there's a lot more open space in the very center. And you can see the birds jumping from the bottom, center, top tiers. And if you watch, you occasionally see them fly toward the back of that video from one side of the housing structure to the other side of the housing structure. But again, the birds have the full access to move in that horizontal and vertical space. They have that scratching area here in the center, and you can see that they, on the bottom left, they have some wire or some fencing that they have put along the bottom to restrict the ability of those birds to necessarily all go under there at one point in time to help reduce some of the piling behaviors and other negative things that may come about from cage-free. Now, this is another type of cage-free system, and we'll kill some sound. But you can see in this one, the birds are required to enter the housing systems from the very bottom on either the left or the right. And then they can move internally through the housing system to the top. But there are gates down that will not allow them to jump from the second and third tier down to the ground floor. And so this is a restrictive entry aviary system. So what are some of our challenges when we really start to look at cage-free? Well, first and foremost, we're now having to deal with litter quality. When the conventional cage, it's not something we've ever had to really manage or think about. But as we introduce the cage-free flocks, we're going to have to deal with that scratch area. And so we're getting caked litter, we're getting buildup of feces. In some barns, if it's along the perimeter of the barn where they're getting a lot of condensation during the winter months, when the cold air is coming in, it can literally look like a pond with the amount of water that has now gone down into the litter, and they didn't have an approach on how to actually manage that. So there's a lot of issues that we need to investigate and work around there. The other challenge that we have in cage-free facilities are floor eggs. And so if we're giving birds full access to go wherever they may desire, we also have to accept that they're not going to read our guidebook. And while we may ask them to lay within a designated area in those nesting boxes or nesting areas, we may find that for the most part, sometimes they will, but there may be those hens that choose to lay their eggs wherever they so desire. And so now we also have to deal with eggs that are being mislaid. So they're on the floor, they're in other parts of the housing structure that we wish them to not be present. And we have to do that daily collection and figure out how to deal with those challenges. We also know that we could have a floor type system. So another type of housing system to look at here where we have the slatted floor. And those birds then can easily transition from that scratch area to the slatted floor and then into those nesting areas to lay their eggs. So what are some of our advantages then? If we try to stand back and look at cage-free housing as a whole, we know that we're trying to increase the consumer demand. And so we're trying to move to where the consumers are perceived wanting us to head. We're doing it because we recognize it gives those birds more natural behavior, and that can be both positive and negative behaviors. We also know that it gives them the ability to dust bathe. And so those birds have the access then to that litter substrate to perform more of those natural behaviors. They, in theory, have the ability to roam from one end of the barn to the other. However, what we're unclear of from a research perspective is if we have 80,000 birds that have full access to that barn, how much of a space do they actually use? Are they using that entire facility? Are they really only confining themselves within social hierarchies to smaller sub pockets throughout that barn? And we're giving those birds more space. Now, our disadvantages. Well, we know that birds are very social, and so we're increasing that social stress by giving them these very massive populations in which they have to interact with individuals now. We know that we're challenging our eggshell cleanliness because we're having these mislaid eggs and we're exposing them to more bacteria. And we also know that another disadvantage is the fact that we're exposing our hens to more parasites and the potential for more diseases. And so we're starting to see this resurgence of diseases and parasites within laying hens that has not been seen in the last 60 years as we transition from this conventional cage to the cage-free environment. So we've got a few more to kind of complete our spectrum of housing systems. So we'll get down here to free range systems, which means that those birds may have an area with which they can be fenced in, and they have access to the outdoors at all times. And it could also mean that they have a mobile chicken coop that may be moved from area to area. And the idea is that they're in these paddocks where they will have the plants that they want to forage on, and whatever they can get from the consumption of those plants is what they can gain nutritionally. So to give you some perspective, this is a facility of about 5,000 laying hens. That is a free range facility. And you can see here that up around the house, those birds have completely denuded any sort of vegetation. And when you walk out, especially after it's rained, it just becomes a massive mud hole. And within this paddock here, you can see that the birds have continued to use this space quite actively, removing most of the vegetation. But you can see here on the other side of the fence that they have very lush green vegetation that those birds can go to. And so one of the things that we have to factor then when we talk about free range is we also need to factor in pasture rotation and some of those management practices as well. So we also know that we're going to have more exposure to predators. Again, they can express more of their natural behaviors. And, you know, we could have something like I showed you previously, where it's more of a fenced in permanent. It could be something more like this, where this is one of the electrical fences that is run by solar. So you can physically pick it up and reposition that fence and move those birds throughout the day or throughout a period of time. And then just some more pictures. But again, the important thing to notice is that those areas directly around the house, in all instances, are completely void of vegetation. Where we see the lush green grass is where those birds have not traveled. And so we also have to consider then, what are ways that we can make those environments more attractive to those birds in the pasture to make them want to go out and utilize that full pasture or paddock area that they're being presented with, as opposed to staying within that 5 to 10 foot perimeter of the house. So some of the advantages, it's allowing those birds to exhibit those natural behaviors. They have that free access to roam wherever they want to go. And typically, if they're in a free range system, we're going to see those yolk colors will be a darker hue as a result of the carotenoid ingestion from those plants. Some of our disadvantages, though, we know that we're going to have more disease exposure. We're going to have increased predation, and this can be both by land and by air. We will have a greater incidence of eggs that are dirty or mislaid, or maybe we can't even find our eggs, depending on how you are managing those birds. And so it really means that we have to bump up that management aspect when we start going to the very extensive aspects of hen housing. We also know that those birds are going to be exposed to inclement weather. And the one thing that really hasn't been investigated yet is, over that period of time, what is the increased nutrient load being deposited directly around that chicken coop? And is there going to be a time in which then you may no longer be allowed to have hens that have outdoor access around that coop because you are not removing enough nutrients from the land that those birds are on year round compared to other practices that we could be employing? So, broad overview, different housing systems, where we've been, what are our challenges and opportunities? Well, first and foremost, it's coming down to genetics. We know that there are differences between white birds and brown birds when we talk about management and cage-free housing systems. They have an affinity for nesting, with whites tending to go to nest boxes more often than brown birds. We also know that there are strain differences. So even though we may have an LSL brown that does amazing, we may then go ahead and get a highline brown and it does not do well at all. And so not only do we have to think about the backgrounding from a genetic standpoint of those birds being white or brown, we also then have to understand the nuances of each one of the strains that we may be using. And then what is that end product, right? And what I mean by that is, if we're looking for eggs that are going to a breaker market, or we're looking for eggs that may be going to the table egg market, we may have to think about what type of genetics we're putting in cage-free. So if you go to a consumer, you ask them about cage-free, they're going to tell you they're expecting to see brown eggs. If I am producing cage-free liquid product, I don't care what color those eggs are that are going to the product, unless there's a specification for that product. I'm likely going to want to use white birds then to produce those eggs going to a breaker. And so we have to think about that end disposition of those eggs. The one area that is really starting to gain some traction right now within the research arena is the backgrounding of pullets. And it is becoming, there was a lot of emphasis on making sure we can move our laying hens into cage-free housing. We want to move them in at 1 square foot. And that was where our focus was. The downside is the conversation wasn't occurring that we need to think about how we're raising our pullets so that they can successfully lay eggs and perform in these cage-free environments. And so we need to think about group size of pullets, stocking densities. We need to think about the type of enrichments that they're exposed to and when they're exposed to them. It is very difficult to take pullets that are reared in a cage house and then put them on the floor. They will struggle. If we take birds that have been reared on the floor and then put them in a cage house, they struggle. So what it's telling us is, if we're trying to move from a cage house to a cage house, then we should rear those birds in the same type of an environment that they're going to be moving into. So with cage-free, if it's a complex environment that the hens are going to end up in, we really need to think about trying to present a complex environment for those pullets to navigate early in life. And what I mean by complex is providing lots of perching, if we're going to provide ramps, if we're going to provide platforms, other areas for them to be able to navigate to and from within that housing system, we want to give it to them early in life. We also need to be thinking about our lighting. How are we lighting our birds? Are we using sunrise, sunset? Are we using LEDs, incandescents? Are we trying some of the newer lighting technologies that are out there being used in industry right now? What is our method of attack? We also need to think about our pullet uniformity. companies right now are struggling with pullet uniformity, going from cage-free rearing to the production house. Really, if we think about it, that shouldn't surprise us. We're giving those birds the ability to be more active. We're actually losing some of our management skills because we don't have the ability to identify those birds that may be on the bottom end of our uniformity curves and giving them that extra TLC to help push them more towards the median. And so we're seeing a much wider distribution coming out of cage-free housing. And so those are all things that we're trying to think about. How can we start to approach them so that we can have a more uniform pullet going in to that production house before she starts to lay eggs? We also need to be thinking about our lighting and feeding schedule. And so that sunrise and sunset is actually very important within a cage-free environment, within extensive housing systems in general. We want to be able to give those birds that sunrise to bring them on in the morning, give them their lighting schedule for the day, and then that sunset at night is going to be very important to make sure that we're programming our lights appropriately. We want to have the ability in our systems where we can dim one set of lights and maintain our lights within our housing system at a brighter intensity. As those birds then is getting dark outside or throughout the entire house, they are more attracted back into that housing system because those lights are still on. And so we have to really think about our programming and how we're pulling our birds off of the floor back into our housing systems so that they A, utilize those perches, but B, in the morning, hopefully it's easier for them to navigate after or during that sunrise to get to the nesting area to lay those eggs. The other thing to think about is it means we also have to contemplate our feeding schedules. Traditionally, it wouldn't be that big of a deal to run maybe 3 feedings a day, and we called that good in the conventional house. With the fact that our birds are much more active within these cage-free environments, we need to feed them more often, and we also need to do short jaunts. And so it may be that we do a full feeding in the morning, shortly after lights come on, or maybe we're going to wait 2 hours and do it after they've laid some eggs. And then we're going to have some stimulation feedings where we're only going to run the belts maybe halfway through the house, just enough to pull everybody back into the housing system to go to that feed to eat some more and try to get to meet that nutritional demand that they are experiencing. So it really means from a management perspective, we have to think about our lighting and feeding schedules and how we're using them to get the birds, A, to either do what we want, or B, to get them to come back into the system when we desire to get food and water. The other thing to think about is movement. Our equipment layout is going to be important. And right now we do a very good job at trying to design equipment that we think is ideal for birds, but really it's still pretty manageable for us as humans and for the labor. But we may need to think about the fact that if I've got a row in my housing systems that are 3-foot difference, and I'm going to allow those birds to jump from here to here, can those birds make that 3-foot jump? Or do I need to say, okay, I'm either going to have rows that are going to be about 2.5 feet in distance, or I'm going to have to go rows that are about 8 feet in difference. So that way the birds either more successfully make those jumps if it's narrow, or if they're going to jump, they're just jumping down into a common scratch area and they're not trying to jump from one housing system over here to the other housing system in the row beside it. We need to think about where our perches are located and how much perch space we're providing to those birds. And no matter what we may think, while we may say these are how we're going to define our perches, I can guarantee that those hens will find whatever areas within the housing system that they would like to perch on, they're going to utilize that as well. Does that mean you should turn around and count that as perch space? Absolutely not. But you should be watching for areas within your housing system then to say, okay, if they're going to try to get to this bar that's really kind of a bizarre location for them to get to, is there something else that I should install in my housing system to help them navigate more successfully to get to that bar that they're trying to go to? We see mixed use of ramps throughout the industry. And so in some instances, they're heavily used by companies, others they're not. Ramps can be very effective in helping birds navigate from the various tiers within that housing system and not always relying on them being able to jump down or jump up. If we think about it, as those birds get older, the odds are we may see more of them start to use ramps because it may be easier for them to navigate instead of constantly jumping. We also know that we have some skeletal issues as we get out later in lay. And so we may see some inadvertent skeletal implications by having those birds constantly jumping, where those ramps can hopefully ameliorate some of those problems. The other thing is the height of the aviary system. So within a conventional cage, it's not uncommon to have 4 or 6 rows, a walkway, and then 4 or 6 rows above it. In a cage-free house, we need to think about how tall that is, not only from the ability of us to be able to see in there to monitor the birds and how they're doing, but if a bird is now 15 feet above in the air and she goes to jump off that top tier and crashes into the ground, what's going to happen? And so we have to also think about how those birds are utilizing that 3D space. And so that height is going to be important. So personnel. As I have indicated, we have a lot of management challenges that are now being presented to us. And so we need to think more about the backgrounding that we have in our personnel that are coming in to work in our facilities. Do they have experience with cage-free eggs or any sort of cage-free production in general? Do they have an understanding of bird behavior? And we may have different levels. If I come in as an owner, I may be expected for this. If I am the manager, I may have this. And if I'm in the house every day, I may have this type of training that needs to be provided to ensure that I'm really monitoring my birds to understand, wow, there's something wrong with my birds today. They're not acting right. Or you walk in and you notice something, and when you walk in, you can pick up right away that we need to get somebody else out here to take a look because there is something evidently wrong. And so it's a different level of training that we need to start expecting that we will deliver to our personnel in these cage-free environments. Time expectations, it is not scalable. We have some companies that are playing around with trying to manage cage-free facilities like they do with conventional cage facilities. And if you ask them, they may tell you they're successful. You ask them on a bad day and they're going to tell you it's absolutely horrible. And so we cannot make a translation between one worker in a conventional house monitoring 50,000 hens is the equivalent of one worker in a cage-free house monitoring 50,000 hens. It does not scale. And it's just because of the complexity of all the new management things that we're expecting those laborers to be able to pay attention to as they're working within these houses. And then we're also going to be faced with labor availability. We know that with the increase in scratch area, there's an increase in dust and things within the cage-free house. And so it may be harder to find workers coming into extensive environments because of the working conditions compared to what we have in intensive housing systems. And so we also have to factor in that availability as well. So we've talked a little bit about the litter quality and that ability to forage dust, bathe in it, scratch. And we're trying to make sure that within the same area that we're limiting the amount of mislaid eggs. We need to make sure that we're paying attention to that litter, not only from the standpoint of, is it wet, slick, clumped, whatever you want to call it, but what is the depth? Because we're starting to see that if we're too deep, we're actually promoting hens to come down and lay those eggs within our scratch area as well. And we also have to look at what impacts it may have on the bird welfare. So when we talk about the welfare concerns, which I think is probably one of the bigger caveats that we have as we go to cage-free, everybody's perception is we're giving them more space, we're giving them the ability to perform all of these wonderful dust bathing and positive behaviors, but we, for some reason, cannot seem to think or keep in mind that there's also going to be some negative things coming along with it. Those tend to be cannibalism, and it's not uncommon to have cannibalistic bouts within our cage-free facilities. We're seeing an increase in various ectoparasites. This keel bone issue that has not really grabbed hold here in the US as being of a major concern is a very big concern over in Europe right now. And there's lots of teams trying to approach the keel bone and get a better understanding of what is going on and what can we do to try to ameliorate the issues that we're seeing. Foot pad dermatitis, we're starting to see that in laying hens now. We have to think about our space allocation and how much room we're giving those birds. Same with that nest box space and also with the perching. So we have our list of things that we have to keep in mind and pay attention to as we move to these different environments. And so the one way that we can do this is by doing this welfare assessment. And so it's a standard protocol. You evaluate 100 hens in the system, and typically you would want to do this at least 3 times during the flock cycle. And what this would do then is allow you as a producer or as a third party to come in, and you can look at some defined parameters to actually see what is the welfare of those birds. Now, this is an assessment that was developed in Europe, and it is a very extensive assessment, and you can do the full assessment. The problem that we have found is that we tend to not have some of it translate to us within laying hens here in the US because of our size, right? Within Europe, you may have 250,000, and that is your flock. The facility I'm at here today, they have 4 million birds. And so it doesn't really translate on some of the parameters, but it does allow you to have that baseline assessment. So if we go in, and this was a project that we ran with the Coalition for Sustainable Egg Supply, and we looked at conventionally housed birds, enriched housed birds, and aviary housed birds in a commercial facility over 2 different flocks. And you can see here that if we look at some of these parameters, we see some very big differences depending on the types of systems we're in. So if we look at the foot problems, we saw a lot more foot problems in the conventional cage. We saw some in the enriched, but we really had severe foot problems in the aviary. If we look at the feather cover, which is it can be used as an indicator of aggressiveness amongst birds, we saw that there was a lot on the throat and belly. So right here on the front of the bird in the conventional cage, we saw the same thing in the enriched as well as the on the top of the head. And then when we looked in the aviary, we tended to see more of it just on the head. And so if we see more of the feather cover loss on the head, it would be an indicator that we may have more aggressiveness, hen-to-hen pecking. So it's a quick snapshot, but it does give us that even though we think enriched, or even though we may think that extensive housing systems is great, and it does provide a lot of positive benefits, there are also some negative things we have to think about as well. And I know that that is 10 o'clockly long. So thank you for your time, everyone. And the foregone conclusion is as we move to extensive housing systems and we move to whatever our housing systems may be in the next 50 years for the laying hen industry in the United States, we need to keep in mind that we have very positive things that can happen, but we also have some very big challenges that are facing us right now. And it's not going to be an easy fix. It will take something probably 10, 15 years before we can really dial in our management practices to address some of these major concerns. As we move into precision agriculture, our hopes are that we can start to address some of these problems that we are faced with a new set of tools that aren't currently available. Thank you very much.
Thank you, Dr. Kutcher. Any questions for Dr. Kutcher? I have a quick question. According to your research finding, like a CSES project, cage-free and an enriched colony, which system has better animal welfare?
Yeah, so the nice thing about the Coalition for Sustainable Egg Supply is I will never answer that question for you, Li Long. So I have all the data there, and if we start to look at the pros and cons, we would see that there tends to be more positive things within the enriched colony compared to the aviary. But at the end of the day, that is not my decision to say one is better than the other. It is the decision of the consumer or of the egg producer to say, these are my priorities, and this housing system checks those boxes of alignment. And so this is the way that I would prefer to go because it, to me, has a better welfare outcome compared to this housing system.
Thank you, Dr. Kutcher.
You're welcome.
If you have any question in future, you can reach Dr. Kutcher, or we can forward the question to all our speakers.